Good morning, everyone, and welcome to the opening debate of FII 9. Today, we'll begin with a question that sits at the core of artificial intelligence itself. Do large models truly reason, or do they simply mimic reasoning so convincingly that we've mistakenly understood imitation for reality? In 2025, OpenAI's abstraction layers and reasoning argued that multi-step inference can form early causal structures. Anthropic's 3.7, from simulation to causation, challenged that, showing that reasoning collapses when tasks move beyond training distribution. And Cartesia AI, whose CEO Karan is here with us today, contends that reasoning emerges only when language, sound, and image or vision are fused together in a multimodal cognition rather than pure text. We've built systems that appear to think, but the question remains, do they really think? Joining us to unpack this are four exceptional voices here with me today. We've got Amir Husain, chairman of WorldQuant Foundry. We've got Karan, co-founder and CEO of Cartesia AI. Husain, founder and CEO of AI Explain, and Dr. Abdel Mahmoud, founder and CEO of Anterior AI. We'll explore 3 rounds: whether thinking models are genuine thinkers or fluent imitators, whether world models bring us closer to real reasoning, and finally, whether smarter training and alignment can bridge that gap. Let's begin. Round 1. Are thinking models real? Are they real thinkers or just verbose imitators? Our first round asks, do today's models really think? Or do they really reason? Or do they just produce patterns that look like they reason? Dr. Abdel Mahmoud, you'll be taking the early delivery of the remarks. Why don't you go ahead?
Shall I step here? Or?
Just stay at your podium, actually. Keep it really
Hello,
casual.
I think they do in the ways that matter. And what I mean by that is, and to give you some context, so we run a company where we use AI to kind of do the work that clinicians do, but inside health insurance companies. Review hundreds of pages of charts and kind of decide whether physiotherapy is more appropriate or a knee surgery. So I kind of asked the question, do doctors genuinely reason? And I think that is also a nuanced question that we're learning more about, in a sense that 95% of practice of medicine, and I say this as a clinician myself, is actually following guidelines and steps and logic that's already been predetermined for you. A patient comes in with a certain temperature and a certain heart rate. You follow A protocol or B protocol. So in a sense, our models do reason because when they go through these 600 pages of clinical information about a patient, they're going through and extracting certain things and then mapping them to guidelines, almost like logic that's being captured, and then producing the output of, yes, they require physiotherapy, and here's the chain of thinking that led up to that. So could you argue that's mimicry? Yes, but maybe your physician is also practicing mimicry.
There's some limitations though, right? The data itself is really guiding the models. Let's say you're going into a space where you're not actually, you don't have the data that allows you to understand. What happens at that point? It really comes down to true reasoning.
Yes.
Could be helpful in that case.
Yes, so that's a very good point. And I think kind of reasoning out of distribution or reasoning over patterns you've not seen before is something that, I'll keep bringing it back to clinicians, that your doctor shouldn't do unless they're a specialist in their field. So in a sense, we will only operate in areas where we know that our precision and our recall are accurate and reliable over thousands and thousands of examples before deploying this in a way, and also do no harm. So I think in a sense, you are right, and I'll concede that point. But fundamentally, that is also the thing that physicians do. And I'll end with this point that there was a study done with judges that before lunch, they were more likely to convict someone than after lunch. And if you ask them for their chain of reasoning, it will sound bulletproof. But maybe it was just that they were hungry, and that's what made them do the decision. So even human reasoning is also flawed to some extent.
So in order for us to learn how to think, we need to learn how we think as well.
Maybe, yeah.
Thank you, Dr. Abdel. To respond, Amir Husain, please go ahead. You will have 3 minutes.
Okay. Same question?
Yes.
Okay. So yes, I do think that models, neural networks can absolutely reason. There is a proof regarding the universality of neural networks, which says that given enough data, a large enough neural network can approximate the results of any function to arbitrary precision. And this is mathematically proven. The practical issue is how do we get there? So if you assume that the math isn't wrong, which it is not, then all of the rest of the discussion becomes how do you equip neural networks with the tools that allow it to constrain its search? Because in many ways, a neural network is producing tokens, word after word, in the case of an LLM. And what you want is for those words to be produced in succession that mimic logical reasonings. For example, inductive logic, for example, Plato and Socrates, and so on, and formal logic. Now, can that happen? Absolutely. But the distribution of words that these models learn is vast, and therefore the question is, how do I get the model to constrain its output to create the right sequence of words which would be logically consistent with inductive logic, which would then give me an explainable proof at the end. Now, in order to do this with general purpose trained models, one generally has to marry additional tools. So if you are familiar with artificial intelligence and you think about a neurosymbolic system, in the very simple conception, an LLM combined with something like Prolog or something like Lisp, well, these systems can then produce hypotheses in a language that is designed for inductive logic, and at the end, arrive at a conclusion and tell you why or why not. So just to wrap up, absolutely, by mathematical proof, we know these systems can do that.
Thank you so much. Question for each. Abdel, if reflection itself is reasoning, can intentless systems ever understand?
Yes, within constraints. So even if they are intentless, it's our purpose, and especially when we use them, we're not kind of letting them loose. We give them the intent, we direct them in a way kind of similar to what Amir said around kind of helping them kind of constrain where to pull up the right pattern to match to, then yes.
And Amir, does it even matter? If imitation works, does understanding matter?
It absolutely matters. Absolutely matters, because imitation is the imprecise, generally imprecise replay of something that somebody else came up with. But it doesn't imply that if you can imitate, you can create, and you can expand the boundaries of knowledge anew. And at least my goals for my AI systems are not just mimicking an act that took place. It's not record and play. It's actually innovate and find and ideate. So yes, to that extent, it does matter.
I agree with you. Let's hear from our other two voices, Karan Joel and Hassan Swaf. Please share your reflections now. We've got your time. Go ahead.
Yeah, I think one area of interesting research and study is actually this area of causal inference. And we're really trying to understand, do our models, are they able to reason counterfactually? So what does that mean? If you think about a grocery store, when they need to decide where to put a new store, they need to make inferences about what's going to happen if you put the store in the middle of the suburbs, do you put it in the middle of the city? And so you're doing all this complex reasoning to try to get to an answer about what it is that your actual utility is out of doing something like that. And we make all kinds of counterfactual inferences every day, right? You're always asking what if questions, like what if I did X instead of Y? This is where we see models not doing very well. So there's been a lot of research recently around trying to study and benchmark our frontier models on whether they're actually capable of doing this type of reasoning. And I think that's like the key bottleneck to be able to actually build really good reasoners is to build counterfactual reasoners, right? Because ultimately that's what tells you that you have a really good model of the world, is that you can answer questions about scenarios that didn't even happen. And if you can do that very consistently, then that gives you sort of a model that's a true world model. So that's one area that I think is quite interesting. And it seems that frontier models today cannot do that very well.
But they are gaining.
They're improving, but slowly but surely, yeah.
Yeah. Hassan?
So the strength of today's large language models is coming actually from building algorithms so that they can actually abstract better. So it used to be that we think about language models like just the prediction of next word, not necessarily something more abstract. And I think this is why some of the large language models, present reasoning capabilities, because they can abstract out the actual form of the words to something more semantically relevant. And I think this is the most important. We are not yet done, I think, in terms of research on how to build these abstraction layers on top of the words which we are reading out of texts. So we're still in the very early days. We're talking still about transformers. There's more things going to come. They're in the pipeline. They're going to be ready for prime time at some point, which can build better abstraction than what we have today. So in essence, while I agree that there is value in symbolic, while I agree that the marriage into logical languages or functional languages might be of value, is of value actually, there is also in the core of how you train the large language model still a lot of space to grow and improve and so forth. We're going to see large language models, even without these extensions, be better and generate value to us.
I agree. Thank you for that. As with all things with artificial intelligence, we start to see the tension with function and philosophy between looking smart and actually being smart or behaving in a way that really helps us understand how to reason. Let's push further into that distinction in round two. If reasoning requires a model of the world, how close are we to getting there? I think we've sort of touched on that a little bit right now, but let's push further. In the second round, can large models form a general world understanding? And you can take it however you want in terms of vision or just even logic-based. Or are they still pattern matching, which I do think is the basis of where we are today? So, Karan, why don't you start, please?
Yeah, I think I would say we're very far from actually having real world models and reasoners that can actually ingest multimodal information. So the benchmark that I like to use is humans, right? We understand the world in a very rich, multisensory way. We interact with our world at very low latencies, incredibly fast. We're able to process video information, audio information. We're able to actually, if you have touch, all of these different sensors are going into the brain, and we're building a full understanding of our world. Obviously, we've seen with the language models, they're looking at a poor representation of the world, I think, through human text, right? The web is basically a summary of all of the things we know about our world. And we, as humans, have built that summary over the last, millions of years. But it's really powerful to think about what would happen if you could connect AI systems directly to that raw data and those raw signals, and what would be possible if they could actually build representations directly on top of that. Now, clearly today, this is not something we do anything close to, because right now, the best methods that are out there for building these frontier models are taking massive amounts of web text and then pre-training large models on it. We don't even know how to train models on massive amounts of video properly. We don't really know how to deal with long context data or data that's very long streams, right? So we don't actually know how to build a machine that can process a year worth of video data continuously, which is clearly something that as humans you can do effortlessly. So I think all of these challenges are really down to the algorithms, the data, and the architectures that are used to build these models. Now, I'm biased because I spent my PhD working on these new model architectures to be able to solve some of these bottlenecks in long context and multimodal modeling. They're called state-space models, and these are some new things we've been working on. But I do think they're only part of the story, and there's a lot of research to be done to really build models that are getting close to that. But I think it's going to be a big hill to climb.
Thank you. I appreciate that plug for Cartesia. Hassan, please follow up if you can.
Happy to. So I was in the shoes of Karan 20 plus years ago, where we basically built hybrid machine translation systems, where we basically took symbolic approaches and machine learned approaches to combine them to build good machine translation systems, which today, we don't need as much anymore because we have neural machine translation, or the large language model can actually do translations. What I'm trying to say is, in essence, I believe that world models, it's a matter of time when we can actually utilize algorithms which we're using for large language models, maybe whatever is going to come after transformers, that they can actually build strong world models. We are today in a situation where we're not there yet. We need to find ways to hybridize until we are there. And for that, these approaches make actually total sense. But in essence, it's not a theoretical problem, it's a practical problem. We need to find ways to build systems which we can use on a daily basis. And hence, that's what we have. So how close are we that we are actually being able to build something like a child, which we put into the world and they learn everything? There's a lot of components which are still missing. We have an idea in which direction it might go. We're talking about embodied AI, we're talking about sensors. Think about a human. How many sensors are we actually utilizing to be where we are, right? And one of the things which all the models which we have today are not good at is that we learn from small amounts of data. We as humans, these big models, they need so much data that this is a challenge. We need to figure out new algorithms to deal with that. Yeah.
And more data, more powerful compute as well.
Yes.
A question for you both. Karan, we'll start with you. If fusion models simulate causality, like the ones you're working on, is that the same as understanding it?
I believe so. I think that I don't think there's anything beyond being able to simulate things perfectly, and if you can do that, then you understand things perfectly. I think Ilya Sutskever had this really nice example of reading a detective novel, and on the last page, if you have the name of the the person who did it in a whodunit, if you can predict that accurately, then did you really understand the whole thing? Yes. So I do think that the core problem is, can we do this at massive timescales? Because a lot of these models, they break down after a while. But I think you can do that. You've built a perfect representation of the world. If we're all happy, we can all go home.
There's a lot to get there.
Yes.
I think just in terms of depth and such. Husain, if LLMs can predict the world without seeing it, does embodiment, as you discussed in the past, matter at all?
100%. So as I said earlier, building sensors to learn from the real world, embodiment is a part of it. We learn through our physical experience in the world and whatnot. So I think this is very important. And I believe that we are actually the best model for what we call today agentic AI, right? Which is a fusion of different models coming together, having some extra elements to make it having a memory, etc., etc. But this is actually what most likely the learning from the real world is going to be. And we're going to do reinforcement learning. We're going to learn. It's not going to be just train the LLM and it is done. It needs to be something which is continuously learning. So embodiment is definitely a core element about us building models which can understand us and deal with, help us in our day-to-day.
Yeah, thank you so much. Let's bring Amir, Husain, and Dr. Abdel Mahmoud back in for quick reflections. Amir, why don't you go first?
Yeah, I think the two core questions, the idea of an AI baby and the idea of a world model. In the world model, one of the things to understand is that there are principles of physics running the world, and one of them is computational irreducibility. What that means is that you cannot compute inside a computer something faster than it would take to do in real life. There are many problems like that. So what that means is that there are natural constraints on your ability to learn from inside a simulated environment. There's also the idea of chaos, which means that for a small change in an initial condition, you might have a drastic change in the outcome condition. So as you're simulating, you might actually end up getting outcomes that are drastically different. So I think I'll just talk about these two constraints, but to say that we can learn the world or we can build a digital twin of the world totally accurately is just contrary to the laws of physics. So what can we do? What we can do is we can get close, and we can get close within reason. We can make measurements that are germane to the problem we want to solve. So first of all, we've got to lower our gaze to a problem that's solvable. The second thing is this idea of an AI baby. It's actually something that 10 years ago I was working on, and at the National Science Foundation, I went and spoke about it. There are lots of approaches that one can take in pursuing something like this. And I think that some form of self-learning creation that is able to segment knowledge based on very, very basic rules that are imbued in that AI entity, that is possible. The question is, how large of a vocabulary can that baby build? For example, a bottle of milk and mother. These two things come together, these pixels move together, there's an association, but how deep can you go with that fact building and how useful can you make that? It's an open question.
Yeah, and then there's also the learning and teaching aspect of how they go, and so versus just ingest and distillation from there. Dr. Mahmoud.
Yeah, I think I want to draw the audience's attention to something Husain said, which is quite powerful actually, about the current frontier models require a lot of training to learn. You've consumed, as intelligent human beings you are today, have consumed a tiny, tiny fraction of that. And I think that's the key bit. World models, fusion, if it can get us closer to solving that efficient learning, I think that will be a big win for everything.
So we seem split between two worlds right now, one that simulates and one that experiences. Which one produces real reasoning? That's where our final round will take us next. Can smarter training and alignment bridge the gap? Husain, why don't you go from there?
Happy to. So, I mean, like my colleagues here said, I mean, this is a work in progress. We are in the research phase. I mean, there's still a lot of things which can be done. Can smarter training and alignment bridge the gap? Definitely. I mean, smarter training means we need to basically build strategies of learning. And you can do many kinds of strategies of learning. And by the way, not only for the machine, but for the human the same. Like the kid is going to learn. You can go to different kind of schools, and you're going to see the kids flourish here, another kid flourish there, and so forth. Similar to AI. The strategies of learning, the strategies of training, we're still in the early days. We're trying out, and so forth. And you see some of these cool models which are coming out and are open source. I mean, if I look at, for example, DeepSeek, in my opinion, their strategy is very efficient, and that is actually like a jump forward. Now other people are like replicating and whatnot, but we're still not there yet. I mean, we still can improve much more. Also, we think about training like large language model training. We have now multiple layers of training which we need to account for. I mean, the large language model has to be trained. It's an expensive endeavor, costs a lot of money, but then there is layers of fine-tuning to tasks, defining tasks and basically fine-tuning towards them. And the third level is basically real-time learning by using reinforcement learning, by using imitation learning, etc., which builds another layer. And everything needs to be aligned. Everything has to come from the benchmark. We forget that benchmarking is the core of what we do. We're scientists here, so we all think in benchmarks first before we actually do any training. But that is typically when you're basically on the ground building applications. Oftentimes people forget that, and they build things which end up being demos, and when it goes live, they fail. So I think there is some learning here also for the people who are building on top of the AI capabilities.
Thank you.
Sorry, it took a little longer.
No, no problem. Amir, would you care to counter?
Yeah, I think that if the question is it more practical to train with data in the conventional way or to acquire knowledge in the real world? As I said in my opening remarks, one of the things we know is that neural networks, given enough data, will converge to an arbitrary level of precision and will answer the question we need them to answer. They'll emulate any function. So we know that there is nothing constraining that. So there's two variables that we have to solve for. One is how much data do we have, and the second is what is the quality of that data. And in many domains, it's not possible to have all of the data available beforehand. It's also not possible to, years ago, when you collected that data, to have known what an embodied artificial intelligence will find relevant. So in other words, there are some elements of measurement, some kind of sensor. That data was missing from the original set. So oftentimes, you take what you have and you try and train a model on it, and you realize that one of the germane elements of data were removed, were never captured. So therefore, I think that capturing data in the real world when you can is very valuable. Work that we've done with the Air Force, work that we've done with power producers, work that we've done with oil and gas companies, in almost all of these circumstances, we found that legacy data goes so far, but really when you fully want to develop a useful AI system, there is an element of let the thing go out and learn and adapt. Embodied AI is the next thing. It's extremely important, and one of the reasons why is it because it can acquire its own data.
Excellent point. There's also so many limitations when it comes down to the type of compute that's required to really enable that kind of thing.
Yep.
A question for you both. Hassan, can alignment systems truly shape understanding or only polish mimicry?
Yeah, so like Abdel said earlier, the boundaries between mimicry and understanding are a little fuzzy, right? I mean, we are all, I think, quite on the same page. Now the question is, what do you define as understanding? And then you can answer the question. So from my perspective, I mean, alignment is going to be important. Something in addition to like alignment to the task is also important, like policies, security, data needs to all be part of the system which we are building, the systems which we are building, which are basically an extended arm of alignment, has to be an extended arm of alignment to keep basically our systems safe and useful. So in essence, I mean, for the one task, it's going to be just mimicry. For the other task, it's going to be real understanding. It's a definition of the benchmark which you need to look into, whether it is the one or the other. So I'm going to keep it a little open here. Sorry.
That's fair. Amir, if architecture is still limiting cognition, what do you think in terms of breakthroughs are needed next?
I'm a huge believer in neuromorphic computing because today all of the neural architectures are linear algebra based. So the way things work is you've got a bunch of layers and you've put these into GPUs and you basically do a multiplication across layers in serial to get to an outcome. And this is not how the brain works. The brain is able to, for example, fire a neuron in the middle without requiring this end-to-end multiplicative linear algebra process unfolding. And this has many, many problems in the way that we've emulated the brain. One is power consumption. We need now a data center that is less powerful than a brain. A brain uses 20 watts. Our data centers use a nuclear reactor, so completely ludicrous in terms of power usage. Secondly, that fundamental temporality, the idea that a neuron can spike at any point in time, in human brains actually provides a signal. That signal is missing from the current emulated neural network architecture that all of us have been spending hundreds of billions of dollars building. By the way, on GPUs that'll depreciate over 3 years. So the real passion that I have right now is how can we take neuromorphics and make them really, really practical. Pull them out from the realm of academia and research labs, and my partner and I have just launched a company to do exactly that. So we've actually been looking at this problem very deeply, but 20 watts, gigawatts, doesn't make sense. Cortical columns, no cortical columns in emulated structures, doesn't make sense. And this idea of temporality and synaptic firing being absent from our current models doesn't make sense. I think that's the big opportunity.
Makes sense. We also need a lot more advancements in input sensors to really enable a lot of those types of things.
Sensors,
Exactly.
everywhere.
Dr. Abdel Mahmoud and Karan, maybe some closing reflections from you both.
Yeah, I was going to say the question was smarter training and alignment. And I think smarter training, yes, would lead. I mean, that's a kind of a general statement. And of course, what kind of smarter? And I think with alignment, I don't want to be reductive, but I like to think of an analogy for alignment training as almost like teaching manners, teaching what to say. And there could be an illusion where the smartest kid in the classroom, according to the teacher, is the one that's the most well-behaved. That doesn't usually translate into intelligence, although it's correlated. So I think alignment is a dual-use thing, and you can overdo it.
It's an amazing paper that just came out from Thinking Machines on the teacher-student distillation work. Karan?
Yeah, I think we're going to need enormous amounts of compute and hopefully depreciate it over many more years than 3. But I think a lot of these ideas are obviously really interesting, like neuromorphics and so on. I think for me personally, I'm really excited to see how far we can take the backprop deep learning approach, and what kind of changes do we need to make to these deep learning models to make them much more efficient? I do think that these models are 100,000 times less efficient than they need to be, even without moving away from the core paradigm, because of the way that we process and train these models and how we learn over data. So I do think there's a lot of room there, but the experimentation that's required, I'm sure everybody will agree, to actually discover new ideas and discover new approaches requires an enormous amount of energy and compute. And that's necessary to get to the next level.
Thank you so much. So perhaps alignment is a mirror showing how close we've come to reasoning and how far we still need to go. Let's turn to our audience before we close. Please scan the QR code now and vote if you can in your apps. Do today's AI models truly reason, or are they still mimicking human reasoning? Take a moment to cast your vote, and we'll share that sentiment as we move to our final reflections. We'll do this really quickly. Each speaker will have 30 seconds to answer one question. What evidence would make you change your mind? Let's begin with Dr. Abdel Mahmoud.
Yes, there's a benchmark, like we all have benchmarks, called ARC-AGI. If there was one to watch, I'd recommend watching that. It's not perfect, but a researcher called Francois Cholet came up with this idea of how can we efficiently learn. They're very easy questions that you could pass, and about 75% of humans are able to pass, 75% of the questions are able to be passed, and AIs in the most research, the best frontier ones, have failed to really surpass the human average. And I would say, if we can crack that reliably every single year, then I think I'll change my mind and say they truly reason.
Amazing. Karan, 30 seconds for you.
Yeah, I would love to see a demonstration of a AI system that's capable of reasoning over a very long time scale with memory. That's one of the key things that I think would make me feel that we're on the right track. In terms of being able to absorb and learn from information. I think there's a conversation around how much data we use and so on. So I do think that's one of the key things, even if it's in a small simulated game.
Amir?
Long-term reasoning with explainability, verifiability. I mean, these are things that are done in hard sciences today, in mathematics today, and I would pose the same problems and then verify.
And finally, Husain.
So yeah, I'm looking forward to, every iteration of AI is basically like toppling the iteration before. I experienced now 5 iterations of those. I'm looking forward to someone to come up with an architecture better than transformers. I'm really looking forward to that. My team is working on some of that to basically allow lesser data, more structured information, and so forth. I'm really looking forward to that. So that would be lovely to see.
Thank you so much. Maybe the real progress isn't in machines acting human, it's in humans understanding what thinking really is. Thank you to our panel, Amir, Karan, Husain, and Abdel, and thank you for our audience for opening the debate at FII 9 with such clarity and energy. Enjoy the rest of your day here at FII 9.